This is the final topic of Glue batch processing, and here I'll be talking about orchestration. First of all, what is orchestration? So let's say you have four jobs: ETL job 1, ETL job 2, 3, and 4. And what you have to do is that the processing requirement is as such that you'll have to run these jobs one after the other. Let's say the ETL job 2 has to be executed after ETL job 1, ETL job 4 has to be executed after ETL job 2, and ETL job 3 has to be executed after ETL job 4 automatically. Now you have multiple ETL jobs here, but how do you control this flow? How do you control the processing sequence of these different jobs? And that's where orchestration plays a role. Job orchestration is a tool which creates an automated sequence of multiple ETL jobs. In AWS Glue, we use the Glue workflow to run entire data pipeline. And we can run crawlers and Glue ETL jobs also. The orchestration tool in Glue is Glue workflow. There are certain limitations of Glue workflow. You cannot run anything other than Glue components. So if you want to run, let's say, EMR step, EMR cluster, batch processing, Athena, etc., then you can use something called Apache Airflow. And AWS provides a managed service for Apache Airflow, which is MWAA. If you want to run Lambda code one after the other, you can use AWS step function for that. But using Glue workflow, we can only run Glue components. First of all, you need to have a trigger which will trigger the entire pipeline. And there are four types of triggers that are available in Glue workflow. The first one is on demand, which will be used to run the entire workflow at a certain point in time based on our requirement. Then you have a schedule using which you can mention that the workflow should run or the pipeline should run every day at a certain interval in time. Then you have conditional. We can put certain conditions for the trigger. Let's say you have uploaded a file in S3, and based on that, you want to trigger the entire Glue workflow. Not only that, you can pass job parameters also. So let's say you have various different parameters that you want to pass in different ETL jobs for different environments or different data pipelines. You can use job parameters to do so. So let's say initially we run Glue job 1, and after that we run a Glue crawler. This is how the pipeline is, because the crawler has to run to capture the latest metadata changes in the various data flows and data targets. After the Glue crawler is run, let's say you want to run another Glue job and then another Glue job, finally you end your pipeline. So this entire sequence of Glue jobs and Glue crawlers can be sequenced or can be designed using Glue workflow, and you can pass job parameters to these Glue jobs. Here I'm showing you only job 1. You can pass different parameters in job 2 and job 3 also. So let's do a hands-on. What will I do is that we'll create an on-demand trigger which will load all the files which are there in S3 to MySQL, and we'll be doing it using Glue API. And then we'll load from MySQL to Redshift using the PySpark job that we have just created. Finally, we'll again load from MySQL to Redshift another table using the Glue API that we have created earlier. Let's go ahead and do that. First, let me show you. These are the tables in MySQL, in Aurora MySQL, and I have truncated all the tables. And all the rows or all the tables do not have any record as such. So we'll be loading these tables in MySQL. And I have emptied the Redshift tables also. I have deleted all the records from cross-country transaction details and cross-border transaction count. And if you do a select star, you see the count is 0, or select count star is showing you 0, and select star is showing you empty results because there are no records in the Redshift tables. And we have these jobs. The first one is PySpark S3 to Aurora MySQL. This is a script which I have used to read various different S3 files using data frames, and I'm loading them into multiple tables like account, transaction, loan, etc. So this is the first job. And the second job is the Glue API that we have created earlier. It will load to the final table. This is the target table, which is the cross-border transaction count. This is the job that we have just created earlier, and this is the PySpark job that I just created in the previous video. So let us go ahead and create a workflow so that we can run these jobs one after the other. Now to do so, we have to go to orchestration or workflows, click on this, and then we'll have to create a trigger first and then add the jobs one after the other. So click on add workflow. This is the name, and there are certain properties which are optional. We can mention the concurrency, meaning how many workflows can we run in parallel. I'm mentioning as 3. And if you want to provide any run properties, you can do so. Using this, we can pass parameters to the job. And let's create this workflow. All right, it has been created. Now select this workflow that I have created. Click on this and there are two options, workflow details and advanced properties. Let's look at the advanced properties first. Here we mention the run properties, meaning what job parameters you want to pass. We do not want to do that. We are not passing any job parameters. So what we'll be doing, we'll be creating a graph. So for that, we'll have to add a trigger first. So click on add trigger here and we can clone an existing workflow or we can add new. I'm naming it as glue on demand trigger. So there are multiple options. We can schedule it. We can put it based on an event. We can have it on demand or event bridge event. So event bridge is an AWS service which can be used to trigger workflow also. I'll select on demand for now and then click on add. So this is the on demand trigger and then I'll have to add node. Now when I say node in workflow, these are nothing but the glue jobs. So I'll be adding this glue API S3 to MySQL. This is the first node. And then we'll be adding one more node here. And you can mention the trigger logic as start after any watched event or start after all watched event. Let's name it as trigger 2. And here I'll be adding one more node. And the next node would be glue API OLTP MySQL to OLAP Redshift. This is the one that we had created earlier. And that's it. There are no other triggers that we want to add. We can add parallel triggers also. Let's say after this is completed, we add one more trigger and parallelly we can execute this job. But rather than that, I'll be adding one more trigger and I'll start after any watched event. I'll name it as trigger 3, click on add, and then we'll add a node. And this one would be the PySpark OLTP MySQL to OLAP Redshift. So that's all. I do not want anything else. If I click on this, it will show me only this jobs. So the first trigger is an on-demand one. Then this is the job, which is glue API S3 to MySQL. Then another trigger, I can change it. There are no other nodes as such. There's only one node. Then another job, another trigger, and then another job. That's all. So the workflow has been created. I can look at the history also. Currently, there are no history. Now I can run this workflow, but you can add glue crawlers also. So here we have jobs options, all the jobs that we have created. And if you click on crawlers, let's say I select this crawler and add it. So this would be executed in parallel after trigger 3. That's all. And now let us go ahead and run the workflow. So it will take a fair amount of time to execute this workflow. It has started now. So it should execute all the jobs one after the other. Once it is completed, then I'll come back. So the workflow got completed and it shows that the status is completed. And this is the workflow that I had run here. Let's look at the history, what happened in the job, because we can look at the job or we can look at the workflow, what happened. So click on history. Here it shows it has been completed. Now it does not necessarily mean that the jobs were successful. So even though the jobs fail in between, it would show the status of the workflow to be completed. So to look at the individual run or to look at the job run, we can click on this and then click on this view run details. And this can be done while the job is in execution state also, or while the workflow is in execution state also. Click on run details and here it gives you the details of run ID, the name, the status, the start time, end time, total duration. It took approximately 17 minutes. And then we can scroll down and look at whether the job actually succeeded or not. So we see that the on-demand trigger was successful. Of course, it has to be successful because we had executed the trigger. Then the first job, which is glue API to S3 or glue API S3 to MySQL, it was also successful. Because this was successful, the trigger 2 was also successful, but the second job, which is glue API OLTP MySQL to OLAP Redshift, failed. Now, because this failed, the remaining jobs did not execute. And if I click on this, it will give you the details, what happened, why it failed. This is the name of the job. This is the description and the status is failed. Now here it gives you the job run error. As you can see, it says that the fail line number is 84, wherein it got an analysis exception. And the exception was that column or function parameter with the name transaction ID cannot be resolved. This is the error of this job. If you want to go further into the details of this job, we can look at the job itself, which is glue API S3 to MySQL. Click on this and then click on the runs. Sorry, this is not the one. This is the job that failed, and we can get to the runs, and this is the job which failed. Let's look at the error, and the error said that the column or function with name transaction ID cannot be resolved. Line number 2, position number 8. Now if I go to the visual ETL, I do not think there is any error here, because the output schema actually contains the transaction ID. So why this error might be? Now let's go back to the workflow again. Let's look at the previous job. It is glue API S3 to MySQL. And let's look at that job, which is glue API S3 to MySQL. And here we are not loading any other tables. We are just loading the ledger table and the account table. That's it. It is not loading transaction table. It is not loading any other table whatsoever. So it seems like the precursor job or the first job itself was wrong. Now, because the table was not loaded, that's why it was giving error while creating the data frame. To fix this, I have created a new workflow. This is the first trigger. This is the PySpark S3 to Aurora MySQL. This is a separate job which is actually loading to all the tables. Now let me show you that job, which is PySpark S3 to Aurora MySQL. It is reading from all the data frames and loading to all the tables. So now I'll execute this workflow using the run workflow option. So I have already executed the job earlier. This is the one, and I can click on view run details. The status is completed, and here we see that all the jobs got completed successfully. Now I should be able to see the count in the tables, and I should be able to see records in the Redshift cluster also. This is Aurora MySQL output, and I'm getting count from ledger, customer, account, and transaction. So the job actually got completed successfully. Let's look at the Redshift output. The cross-country transaction details has 12 rows, just like before, and cross-border transaction count has 192 rows, just like before. So let's do a select star from both of these. This is the cross-country transaction details. We had total underscore amount earlier also. Here total count, long, etc. I think I did not change the code properly. And this is the cross-border transaction count. So all the jobs got executed properly using the glue workflow. So this is what glue workflow is. And using glue workflow, you can orchestrate glue jobs and glue crawlers in AWS. Now, as I said earlier, there is a limitation of glue workflow. You can only run the glue components. You cannot run anything other than glue. If you want to run, let's say, Athena or Hive or a Spark cluster, that cannot be done using glue workflow. For that, you'll have to use an open source workflow or open source orchestration tool like Apache Airflow. And this is where I conclude glue batch processing. Let's summarize what we have learned so far. First, I talked about glue data catalog and crawler. What is crawler? Crawler is used to discover and store metadata of various data lake tables, lakehouse tables, data warehouse tables, or OLTP tables, etc. And glue is nothing but an infrastructure or a serverless infrastructure to run Spark jobs. When I say serverless, it is not serverless for AWS, it is serverless for users, because AWS still has to maintain the servers or infrastructure to run glue. We can use glue API or PySpark both using glue. PySpark is as usual, there's no difference in PySpark unless you are using targets like Redshift. And the glue APIs are built on top of Spark RDD itself. I have shown you that also in the Spark UI, that the glue APIs are created from Spark RDDs. If you ask me whether you have to learn glue API or not, it is not needed, it is not mandatory. Of course, if you learn it, it would be good, but in most of the cases, you'll be using PySpark in glue. Finally, I talked about glue workflow, which can be used as an orchestration tool to run glue components one after the other, like glue ETL jobs or glue crawlers, etc.